Welcome to iLecture Our next topic on vectors is the product of vectors. And in this case, we're going to start with what we call the dot product, or also known as the scalar product. Now, the reason why they call a dot product a scalar product is because the result of a dot product is a scalar quantity. It's no longer a vector, it's just a number. And also, to indicate that this is a dot product, we put a dot between A and B. So, for example, if you do 3 times 5, sometimes we write it like this, and sometimes we write it like this. You get the exact same result. Well, in vectors, that's not the case. This is called a dot product, so we use a little dot. This is called the cross product, and we'll use an actual cross. And in vectors, it's not the same thing. With numbers, it would be. All right, so now that you know why we use the name, let's see what that is actually equal to. What is the definition of the product of two vectors? Well, first of all, we need to know the angle between the two vectors. So let's call the angle theta. And then what we're going to do is we're going to project the first vector onto the second vector. So to do that, we draw a line perpendicular to vector B to the tip of vector A like this. And this distance right there from there to there is considered A projected on B. Now, what would that be equal to? Well, this quantity right here, the length of that, the magnitude of that, is simply the vector A, which is the hypotenuse of this triangle, times the cosine of this angle theta. So this distance here, the magnitude, is A times the cosine of theta. So now it turns out that A dot B, or A multiplied by B via the dot product, is equal to the length of the projection of this vector onto the B vector times the length of the B vector. So if I go ahead and realize that this is the magnitude or the length of the B vector, the dot product is simply this distance or this length times this length. So what that means, it is equal to A times the cosine of theta times B. So that's by definition the dot product. Now we usually don't write it like that. We usually write it like this. This is equal to A times B times the cosine of the angle between them. So again, written in a more compact fashion, A dot B is defined as A times B times the cosine of theta. Now remember that A and B, without the little lines on top, means the magnitude of A and the magnitude of B. So really what we could have done is we could have written it like this. This is equal to the magnitude of A times the magnitude of B times the cosine of theta. So just don't forget that A and B without a little line on top is simply the magnitude of those vectors. And do you remember how to get the magnitude of the vectors? Well, the magnitude of A is equal to the square root of the x component of A squared plus the y component of A squared. And of course, that's in 2 dimensions. And for the vector B, that is equal to the square root of the x component of B squared plus the y component of B squared. And of course, add them together and take the square root. In 3 dimensions, of course, this is in 2D or 2 dimensions. Of course, if we have 3-dimensional vectors, then the magnitude of A would simply be the square root of the x component squared plus the y component squared plus the z component squared, add it together and take the square root. And of course for B, that would be equal to A up, not A, because I'm talking about the B vector. So in this case, it would be B sub x squared plus B sub y squared plus B sub z squared. So that's how you find the magnitudes. So if you want to take a cross product, you take vector A and vector B, you find the x, y, and z components, you square them, you add them together, take the square root, so you find the magnitudes of the two vectors, multiply that together, times the cosine of the angle between them. Now notice, what if the angle between them is 0? So what if you had vector A like this, and what if you had vector B like this? A and B, and of course they don't even have to be the same length. No, vector B can be like this. Of course, then the angle between them would be 0, and the cosine of 0 is 1. So then when you take the dot product, it's simply the magnitude of A times the magnitude of B. What if they're perpendicular to each other? What if we had vector A like this? And what if we had vector B like this? What's the dot product now? Well, notice the projection of A on B would be 0 length, and the dot product of those two would be 0. And of course, if you take the cosine of 90 degrees, cosine of 90 degrees is 0, and you get a 0 result. There's one more way in which we can find the dot product of two vectors. It turns out that A dot B can also be found by saying that it's the product of the x components plus the product of the y components plus the product of the z components. So notice it's ax times bx, ay times by, az times bz. These are the magnitudes of those, not the magnitudes, not the vectors. And also keep in mind that if they're pointing in a negative direction, you do have to take into account the negative. For example, if I have a vector that looks like this, if this is the a vector, and I have another vector that is like this is the b vector, notice that this will have a negative y component, and so the y component would have to be negative. And if there's no z components, then of course z simply would go to 0. So that's how we find the cross product. Now, of course, you probably would like to see some examples. So in our next video, we'll do some examples of how to find dot products of vectors.